I'm quite nervous. So yeah, I'm Melissa Howe and I work for EMIS Health. I've been there for about 5 years now. EMIS is responsible for creating basically software what the doctors use or people in a healthcare setting. So my main focus for the past couple of years has been testing an iOS native mobile app. So I apologise if some of the scenarios are centred around mobile or around the healthcare setting. So we're here talking about Agile. Agile ways of working are perfect for having feedback loops and acting upon the information we get back from those feedback loops. Without those feedback loops, Agile is basically just a waterfall in iterations. Feedback helps the team improve productivity. We use the feedback loops to improve an individual's performance, the progress on the projects, and we continuously reevaluate the path to the expected desired goal based on tangible data and feedback. So not only do they provide feedback, they help the team to improve their productivity. So I've just included this. I don't know how well you can see it, but I thought it was really good to show how many feedback loops there are throughout the process. So the constant feedback can come in many forms. For example, sorry, it's on a remote box. It can come on feedback from the ways of working through our Scrum practices. So, for example, the retrospectives that we hold as a team. It can also come from the customers via their feedback, whether that be on the functionality, whether they like it or not, or whether there's defects. It can also come as feedback around the quality of the software, which is what I'm going to focus on now. So this comes from the development and testing processes which we are using during our sprints. Shortening this feedback loop gives us confidence in what we are producing in terms of the quality, but also that we're not breaking any existing functionality. So we work in iterations and we plan work into a sprint, and that has been agile. But sometimes we do spend days as an individual person working on a feature, analysing it, coding it alone, and then test comes last. And that's, to me, that's not treating a work item in an agile manner, but it is a trap that we fall into. However, if we plan to work on a work item, work on it iteratively, this allows for constant feedback in terms of the code, quality of the code, and in terms of what we're creating is matching what the PO is expecting of us and what the customer wants us to create. It does also make us more confident that what we're producing is a stable product, there's no issues in it. And if we do break down the work items, we can release incrementally. So break down the feature, release bits at a time. And we can also share work items across many members of a team. So each team member can focus on their part and perfecting it. So if we break down a work item, we can develop each part at a time. We can work simultaneously on a work item, but we can focus on creating and testing each part in turn and spending time on that part until we're 100% happy and confident that it is a good bit of work. So I've just got a scenario here as an example that I've pinched from work. So if we take this user story, it's quite I chose it as something that I thought everyone would understand. So you go to a doctor and they want to add a drug to your record. So that's what the POs come to us with and said, this is what I want to do. So you can break this down into many levels of testing. So just as a quick example, for each one, for a database test, you can write a DB test to ensure that the correct data is written to the database with the correct constraints, such as a unique GUID for that prescription, or checking that lengthily named drugs can be stored in the database. We could also write a unit test for that to validate that you can prescribe a maximum dosage of a drug. We could write an integration test for that to make sure that you can't prescribe something that's going to badly react with something else which the patient is already taking. And we can also write a system test for that to check that the user can successfully go through the system, open up a record, prescribe that drug, and then make sure it's still stored there correctly. So writing the test first gives the developer instant feedback regarding on if the work item is completed to the correct expectations. This can be really valuable for the timings. The tests are defining the behaviour first, and it also means that a developer knows if the work is completed because they'll get that instant feedback from those tests rather than waiting a few days and then it progressed to a test column. Then in a few days' time, finding a bug with it, they've forgotten about it, and then they've got to go back and work on it. These tests also add value in the sense that we can be confident that the feedback the tests are providing us with. If we don't trust the tests, they serve no purpose at all and will often be forgotten about and the results ignored. So I'm going to go on to a few of the different types of testing now and what value they can potentially give you if you think about them. So I'm sure you'll have all seen, or some of you will have seen the testing pyramid now, introduced by Mike Cohn. It shows where each type of testing fits on this pyramid. So the lower down the pyramid, the faster the execution time, the deeper your tests, and the cheaper they are to create. It also shows the quantity of each type of test. So it's a good guide to consider how many tests you would have at each level. It also discourages you from writing too many tests at the UI level and to push them further down the stack. The rapid execution time for the tests lower down the pyramid is perfect for providing rapid feedback. Further up the pyramid, more thought needs to be put into those tests to make sure that the value you're getting back from those tests outweighs the time that they take to run. So there's many types on the tests on the pyramid, but I'm going to focus on these two just for this, so two extremes, and how they fit into a rapid feedback loop and what value they can provide you with. So at the bottom of the pyramid, there's unit tests. Unit tests provide the developer with instant feedback because they're extremely fast to run, take seconds to run hundreds of them. They provide the developer with confidence that the code logic will not be broken by the changes which they are making, or if they're doing any refactoring, adding new code. It's the safety net for them, basically. So common phrases that we hear around the office, the unit tests are there to stop them feeling that way. So how to make them valuable? Well, first of all, make sure that they do run quickly. You can get stats out of them to see which are the longest running tests, act upon that, make sure that they really are providing you with that instant feedback. So some teams come across and say, my code coverage is really high, but sometimes you can create a false coverage and make your code base really fragile, so it's very important that you're unit testing your public methods and not trying to fudge the kind of metric that you're providing. The tests must be deterministic. So if you have a test which passes sometimes and fails sometimes, it's not very useful at all. It does make you just ignore your tests and think they're not really providing me with any feedback. And you can also often waste time investigating a failure when actually it's just a badly written test. And the main thing, name them sensibly. So those unit tests are your documentation for that code. If you hand it to another developer and they want to know what that code is doing, you can refer them to the unit test and explain exactly what it's doing. Again, that's their safety net for their changes that they're making. And run them often. So I'm going to focus on that now. So unit tests do take seconds to run, so there's no reason why they can't just be constantly ran. Running a unit test every time a code is checked in gives the team that instant feedback regarding the code. It also protects the code base, so that the team can know that nothing protected by a unit test can be broken by a check-in. So as well as running them on a check-in, you can run them at every opportunity. So if you're running them whilst you're developing, you're still getting that feedback as you're going along, rather than waiting until the end for your commit. There's tools available for that, so that I know there's nCrunch as a Visual Studio extension, I think, which will constantly run them for you to save you remembering to run them yourself. It also gives you confidence in the work that you're doing. So as you're going along, you can keep referring back to those unit tests, getting the feedback from them to know that you're going down the right path, not breaking anything. They do also alert you. They alert you very quickly if something's gone wrong and if you're going down the wrong path with your development. So I've just pinched some screenshots from the board that sit behind me at work. So there's many tools available to help you to set up a CI system. For example, our code, we store it in GitHub, and we use a plugin called Zapper, which checks that our code has been reviewed by a developer and a tester. Before the code has even been reviewed, the second a pull request is raised, we use, I think it's Git to kick off a job. No. Yeah, but, so build's kicked off. It checks the code builds, checks the workspace is clean, runs the unit tests, and does code analysis. So before the work even gets to a code review, it's already been run through all those checks and given the developers the feedback to make sure that the work is in a state that it could be committed if it passed that. So the unit tests, we get Git to tell a tool called Fastlane to run the unit tests, which are on the left-hand side there. So you can see there we also get metrics back. So we're getting the feedback as to how long those tests take to execute, so we can focus on those tests and reducing the time of them. We can also see the names of them and think about how valuable they are in that process. So we then get a status back, which is on the board there. So the whole team is getting the feedback as to whether the build has failed or not. We can see the progress of the build as well behind us. And it turns red if it fails. So it's kind of a motivational thing, really, to be able to turn around and see a happy green board behind you and know that everything's going well. Just as well, took off on a bit of a tangent just for what one of the team has done. As well as providing feedback to the internal team, they have also used GitHub to even provide progress reports on their work to external members and just used a Git job to do that. So I think it's a really good tool that we're quite new to it, really. We've just adopted it, but we found it very useful in improving the feedback loop, both within the team and pushing the information out as well. So at the other end of the pyramid is system testing. So these tests cover the user's journey through a system, and for this reason, they tend to be at the UI level, especially in mobile applications. So system tests cover how usable the application is. They can also be recycled to run against various screen sizes and web browsers. So it's really useful for us because it saves us having to execute the same tests repeatedly across many devices, many OS versions, screen sizes, that kind of thing. So but they do have the longest execution time. So to make sure that they are providing us with that feedback, they need to be worthwhile. So there's some ways to make them more valuable. We categorize them. So we don't run all of our system tests per check-in because it does take a long time. So on the previous slide, there were 2 jobs. Per check-in, we tag the tests as a category so we can run a targeted regression suite against them. But then we had an overnight job as well, which does keep running all the tests. So we're still getting that feedback first thing on the morning from the entire suite, but we're not slowing down the development, waiting for all of the tests to run per check-in, because we do break down work items and check in a lot, so we'd get no work done if we did that. We also treat our code like production code. So we have methods which interact with on-screen UI elements, and those are unit tested as well. So we have confidence that anybody else who's also using our testing framework can break our tests just from making changes from it. And because we've mocked various page sources that we get back through the tool that we use, it actually makes it quicker to write a new interaction by using the unit tests rather than running it fully against the device. So the other week we decided we wanted to get back whether a button was enabled or not on our screen. So rather than spending ages writing tests that call back to the device to do that, we did it through the unit tests and the mock, and we knew and we were confident that the tests we were writing gave us the feedback that we needed. So when we checked in, it did actually work against the real devices. The tests, again, should be deterministic. So repeated for the last one, if they do fail 1% of the time, you just ignore them, and then the tests become less and less worthwhile over time. So again, by running them all overnight, you are getting that feedback, and you can point out if there's any flaws. You can get reports on if some tests fail more often than others and the reasons why they're failing, so that you can address that as soon as possible to get the tests running valuably again. And So we consider the reusability as well of the code which we're doing, which I'm going to look at now. So we reuse test steps, and that saves a lot of time. The more tests you write, the quicker they are to write because you have got those reusable methods and the reusable steps that you're calling into. We clearly name the methods again, so not production code, but it's internal code to us. It's important that anybody else who's looking at our tests can read them and can also contribute to them. So just as an example of what we've done there, we've broken down the testing steps. So if we put everything into a method, it means that if something does change, it's easier to adapt your tests and update them to that change. So pretty much most applications will have a login screen at the start. So rather than starting off with every test having its own individual login method, we wrap that up, consider the reusability of that, so that if our PO decides, actually I don't like that login screen, we've only got to change it in one place, so we're not holding up the development. We can adapt and react quickly to those changes and make sure that our tests are still going to be valuable and provide us with the feedback. So another way that I found to be helpful when writing both the unit tests and our system UI tests that we write is to write them in a BDD style. So scenarios form a collection of self-documenting test cases for this. So we can talk to other people about them, which is really useful. And it forces you to drive your tests by the behaviours, not the implementation. It is a really easy language for everyone to understand, so it's just plain English. So anybody can review that. It means that as everyone understands the tests, it's improved communication in our team dramatically, and it's improved the trust between us all as well. So we can discuss these with our PO, so we can start off and have a conversation with him and say, what is it that you're wanting? Help me to write the tests, help me to write these scenarios. And then we can be confident that when they're passing, it's going to pass your review because you've already told us up front exactly what you're wanting. It's also helped, especially for the unit test level, the communication and trust between dev and test. So I'm not going to pretend to understand Swift, but by wrapping a unit test up in this, I can review those unit tests and understand what they're testing. So it gives me a bit more of an insight into the test that they're writing, and then the developers can review the underlying steps and be able to check that what they're writing is actually adhering to those. So they're just a few that are pinched off one of the teams at work. These steps, again, they can be recycled. So we've got one team within the business, which I think is a really, really good team with the way they work. There's a couple of developers, there's a technical tester and a non-technical tester. Anybody can write these. So the non-technical tester is actually writing automated tests without writing a single line of code. So they're really involved with this. Their mindset's very good for writing these kind of scenarios and talking through with other people, such as the PO, to really understand what they want. And it means when we don't have a PO approval because we don't need one. We do it first. The PO is approving what we're about to do before we even do it. We just obviously they see it as we're going along because we work very, very closely. And UX are actually also involved in the scenarios that we do, right? So the way of writing these tests as well, the variation's really good. So rather than clogging up your screen with loads of different tests, which are basically doing pretty much the same thing with a few different scenarios, you can just run them. So we've got 2 patients there, which the test data is very, very different, and we understand the differences. So we just get that test to run twice. And if it fails or passes, it tells us which one it's failed on and why. So we can look and think, well, it passed for that one, so why has it failed for that? What's different about them? Let's go back to it and see and address those reasons. Yeah. So I guess in summary, really, no matter what type of testing you're doing, consider how valuable your tests are, and if they're providing you with that short, rapid feedback loop that you need. Keep reflecting back. Use your retrospectives to reflect back on your tests. We do pull that up as well and say, it took me ages to write that feature because I had to wait for all your tests. Let's look at reducing them. What repetition do you have? And we log stories and we do go back and review those tests. They're not there to be a hindrance. They're there to provide you with necessary feedback so that you're confident in what you're producing. It also it makes you feel like you're achieving more and you're developing both quickly and correctly.